Howdy! This is my presentation about earthquakes. I'm Taylor Acevedo. This is for Geology 3100. So, talking a little bit about earthquakes, kind of what they are. We kind of know what they are, right? They're sudden movements of a block of Earth's crust along a fault, right? So, kind of let's talk about how the Earth's constructed so we can understand about these plates. So, the middle of the Earth, we have the inner core, very dense inner core. About the size of the moon, roughly. Pretty big. Then we have the outer core, right? So we'll glance at my notes a little bit. The outer core is more liquid. And the mantle, which surrounds the outer core, is composed of mostly of solid and magnesium-rich silicate rocks. That is surrounded by the crust, which is the outside of the Earth, the rock layer, rocky. And at the upper level, of the mantle, you have two kind of different spheres we talk about when talking about earthquakes. Very common. The lithosphere, which is the top part, rests right above the asthenosphere. And the asthenosphere is a little weaker, a little slower flowing, so it allows the lithosphere, which is kind of broken up into plates, to move around on it. And these plates, these tectonic plates, they'll push past each other and hit each other and things and pull apart. And that's what causes these sudden movements of a block of Earth's crust on a geographical fault. But they can be pretty deadly, right? In China, in the 1500s, there was an earthquake. Over 850,000 deaths were reported. In Tokyo in 1923, 143,000 deaths. And in Haiti in 2010, over 240,000 people died in one earthquake. So, let's talk a little bit about where they occur. Like we discussed a little bit earlier, they occur along these faults and along these plates. So most of them occur along plate boundaries because that's when they move, because that's where they move, right? But some of them occur in the middle of a plate, and those we refer to as intraplate boundary earthquakes, intraplate earthquakes. So some of the geographic regions that are at the greatest risk for earthquakes are along the entire Pacific coastline of North America, California all the way up to Alaska. Lots of earthquakes happen along there, and a whole host of other places. Let's talk about why they occur. So why do earthquakes occur? Well, we kind of touched on it a little bit. The movement of the tectonic plates. There's three different kind of plate boundaries that we talk about. Convergent, divergent, and transform. Convergent is when the plate boundaries coming towards each other, and the more dense one we get pushed under the less dense one. The divergent plate boundary is just the opposite. It pulls apart, right? It causes like mid-ocean ridges and things like that. And then there's the transform, which slide just past each other, like the diagram shows. Perfect. Let's discuss a little bit about when they occur. So, when the tension builds up along these faults, along these plate boundaries, when the tension builds up so much that it can't handle it anymore, the energy is quickly released with a sudden shift. And that, right here as it says, known as elastic rebound, and that's when the earthquake actually occurs. And according to, interesting fact I found, according to the Incorporated Research Institutions for Seismology, earthquakes occur 12 to 14,000 times a year. Most of them are small though, really small earthquakes, hundreds of them a day. But a magnitude of 8 on the Richter scale occurs on average about every 2 years. So let's discuss what we can do to prepare for an earthquake. Preparation, minimizing the hazards. So the U.S. has founded this little program here, the National Earthquake Hazard Reduction Program, and they got some serious goals that they're working on. What they're trying to do is they try to identify areas that are at the greatest risk of an earthquake, and they try to even predict how strong these earthquakes are going to be and what the hazards are going to be from it so that they can be prepared for it. Estimation of seismic risk. So that is crazy. That's just crazy. Seismic shaking hazard maps. So they have maps that show the seismic risk in different areas, and they show which is more likely to for an earthquake to occur. So this helps people know which is the most dangerous place, right? And it's usually short term, like 30 years or so. Again, we have short-term prediction up there actually. But earthquake warning systems, this is interesting. So technically, you can be warned, there's technology that we can be warned of an earthquake up to 60 seconds, up to about a minute before they actually occur. But the reason scientists are reluctant to use them is because of the liabilities that can incur from the small chances of false alarms. So in Japan, they started testing this, and about 5% of the time they were false alarms. But that's still a lot of liability because a lot of hazards that can happen when there's a false warning. So, all in all, earthquakes can be pretty dangerous, pretty devastating. They're hard to prepare for, but they can be prepared for. But enough with the negatives. There's a lot of natural service functions that occur from earthquakes. For example, breaks up the ground for groundwater and energy resource movement, such as like new formed springs. There's some famous ones in Texas. And it can also expose valuable mineral resources when the ground is shifted up a lot. And it also produces aesthetically pleasing landforms, like our beautiful mountains. So earthquakes, they are kind of wild. Keep an eye out for them. And remember, just to recap, they occur along plate boundaries most of the time, and convergent, divergent, transform. Be careful, watch out. Good luck. Thank you.